So now that we've learned how to graph a system of equations and come up with the solution, which is the point of intersection for the two graphs, the two lines in this case, you should be thinking to yourself that there's more than one possibility of something happening whenever I graph two lines. They're not always going to intersect. And so that's going to create a situation where we have some special solutions for a system of linear equations. And so if you look at this concept summary, you can see a visual example and a verbal example of each of those special situations. And so if we look at this first one, exactly one solution, that's what we've been looking at up to this point in time. We've graphed two lines, they cross each other, and they have one point of intersection, so it has exactly one solution. Now, there will be circumstances where we could give you two lines that somewhat look differently because they have different coefficients, or one of them's in standard form and one of them's in slope-intercept form. And you may not recognize that they're exactly the same line, but when you finally get down to graphing them, you notice that one lays right on top of the other. And so if they are exactly the same line, then the points that they're sharing, or the points that make each one of them true, are all of the same points. And so there's an infinite number of solutions to this system of equations. And so we would call that infinitely many solutions. Now, there is going to be a possibility, however, that they never intersect. And if they're not the same line and they never intersect, we know that those lines are parallel. And so if you recall from your geometry that parallel lines have the same slope, if we end up getting two lines that have the same slope and we graph them, they're never going to intersect, and so that they would have no common point or any common solutions. They would simply say that we have no solution. So those are a couple additional possibilities for your solutions to linear equations, to a system of linear equations. And so we have a couple sample problems for you to work on so that you can see how these might play out, and you need to recognize what each one of their answers would look like. And so go ahead and pause the video at this point and work sample problem number 3. You can do part A and then come back and watch the solution, or you can watch part A. You can do part A and B and come back and watch the solutions to both, whichever order you feel most comfortable in. So go ahead and try those now. Okay, I'm going to start sample problem 3, part A. Again, I'm just going to go ahead and convert both of these to slope-intercept form. And you can see here that I've graphed both. I've converted each one of them to slope-intercept form. Now, you should be able to see very clearly that both of these equations end up equaling the same thing. So they're the same line, but we're going to go ahead and graph it anyway. Okay, so you can now see that I've graphed this line, and of course if I graph both of them, they're going to be the exact same line. And so since they're the same line, they have infinite solutions. Okay, very good. So that's an example of the infinite solution possibility. So go on to sample problem part B. I'm going to do the same thing here. I'm going to go ahead and convert these to slope-intercept form and then graph both of these lines. Okay, so you can see here that I've converted both of these to slope-intercept form. Now, if you look very closely, you can recognize that they both have an understood 1 for their slope. And if you recall, if the slopes of two lines are equal to each other, that's going to create parallel lines. And so that right there should give you an indication of what our solution is going to be. But I'm going to go ahead and take the time to graph both of these lines real quick. Now the second one has kind of an awkward y-intercept, 9/2 or 4.5. So you're just going to plot that as best you can. But I'm going to go ahead and graph both of these. Okay, and so you can see now that I've graphed these two lines, and they're very, very, very close to each other, but you can see that they're going to be parallel. And since they have the same slope, they're parallel. And if they're parallel, that means they have no solutions to this particular system of equations. And so those are two additional examples of the type of solutions you could get to a system of linear equations.